It's just a Wednesday day, and it's raining outside. It's not a nice day, you know, but we still have to work. And today we have a nice laptop, and trust me when I say nice, this is a nice one, yeah? This is a MSI. Let me grab the receipt out. Yes. And it's cola damage, you know? The man sprayed some Coca-Cola over the laptop. Coca-Cola is nice to be drank, yeah? But when it's about damage, it's... I can't explain you how much damage can do Coca-Cola on the motherboard. Yeah, so this is a nice i5, it's a MSI GE70. NVIDIA graphics i5. It's a nice laptop. What is doing this laptop? Nothing. We can plug the charger. Charger is plugged, but we have no light. Nothing. And we can press the power button and nothing will happen. Still nothing. It's just dead. Yeah? So let's open this one and try to see what can be wrong there. Oh, we have a seal. Oh, I just broke the seal. It's a sealed over a empty. It's no screw there. It's crazy. Why should put a sealed over a empty hole? Okay. Probably someone broke it and opened this before. Processor, graphics. Even the chipset has heatsink. That's a nice computer. Gaming one. Yeah, this is a nice laptop. Okay, let's open this. Probably under the keyboard will be the damage. We have no light, that means the 3.3 is not there. CD drive. But the Coca-Cola damage is the worst possible damage, you know? And one of the reasons is because it's a lot of sugar inside. Sugar and obviously chemicals. Look at the MOSFET, big MOSFETs. This is a nice laptop. Drive. Yeah, I can see Coca-Cola here. Look at the heatsink. Look, this is a big heatsink from the processor. Okay, we have no screw here. Let's take out the keyboard. The hinge are broken. It's on clamps. Yeah. We'll see on the end. It's okay. Okay, it's sticky, but it's not so much damage. It is. You can see some Coca-Cola here, but not a lot. Dashboard. We have one more screw. Yeah, the hinges are gone. Okay, when you have one more screw here. There and here. Well, here. That's crazy. That's crazy. So I have to take out the heatsink to reach the screw. It's a screw under the heatsink. Yeah, beginning of overheating. Okay, the heatsink is out. Look at the screw under the heatsink. Okay. So let's try to open now. It's one more screw. One more screw. Where? Okay. It's not so bad, but it is. You can see, we can see the damage. The hinge are gone. Look at the hinge. Look at the hinge, the boat hinge. Yeah, we have a lot of damage here. Yeah, it is. Let me switch on the microscope. Check there. Yeah. And we have some drops of Coca-Cola around processor, and we have some MOSFETs with Coca-Cola on it. And we have another MOSFET here. And capacitor with Coca-Cola. What do you think? Probably this is the 3.3 volts driver. Yeah, looks bad enough. Okay, let's start cleaning with this one, you know. See the black thing with this Coca-Cola. Okay, I'll use petrol. Zippo petrol, yeah? And let's see if we can do in my toothbrush, if we can clean this. Okay, looks okay. What about here? Looks okay. What? I think this is switching in salt. I don't even touch the mouse. Okay. Here is some damage. Well, look at the sugar thing, you know? You can't even take out that thing. You see like a sugar mark. What I can say, I'm happy it's not It's not too much damage. It's enough, but it's enough to be fixed, so. I think we still can fix this thing. Water is easy. But Coca-Cola, oh. What do you think will happen when you come with the hot air? All the sugar will get transformed on some black thing. I think that's all. Still sticky. Okay, let's use some magic. Yeah, we have to seal all the affected area, and I will use. Hopefully, it's still good. It's still that chip is still working. I'll use my liquid flux. Not too much air, because we want that flux to go inside. And I can feel the smell of the sugar. Flux. I'll leave that area like that. And I will do the same thing with all the affected parts here. Here, the MOSFET, here. 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 And that's all. Same thing. Ah, no. What? Huh? Okay. Okay, let's try now and check for some voltages. Yeah, we sealed all the affected area. Let's plug the charger and start finding the problem. Yeah? Look at the hinge. Completely gone. I understand it's a big screen, it's 17-inch, but still, you know. Okay, let's plug the charger. Yeah, crazy. Yeah. Wow, that chip is bubbling. Look at this chip, and I did nothing. I just plugged the charger. Look at that chip. So I just plugged the charger. That's all what I did. It's boiling. So check out that chip. It's alive. That chip is alive. Look at that chip. I never saw something like that. This is unique. So it's like it's alive. Look, it's bubbling. You can see that? This is nice. Mm. So probably that chip is very, very hot. If the chip melt the my flux, then it's bubbling. That's crazy. How hot is? Oh, very hot, trust me. Very hot. Okay, I'll unplug the charger. I just unplugged the charger. Okay, so we have that chip, which is getting very hot. Now I know. Many will think, you know, that chip is dead. But I'm not happy with that. Chip is dead. Yeah? Okay. Yeah? Yeah. I don't know about the keyboard, but I have a chip here, it's boiling. Okay. So, like how I said, you know, I'm not happy with that. Just, you know, oh, the chip is getting hot, the chip is burned. No, that's not helpful. That's that's not okay. No, it's not what I'm doing here, yeah? Let's check the 19 volts power rail, yeah? 19 volts. Probably is there, but let's check to be sure. Let me plug the charger. And let's check quickly. It is there. We have 19 volts. Here is some power supply. I don't know what power supplies there. It doesn't matter. You have a lot of power supplies over the motherboard, which all they have 19 volts. Okay, that chip probably is the 3.3 volts power supply, because has voltage when the laptop is off. That's the only power supply who is alive, the 3.3 one. Oh, whoa, whoa. Hot. I know. Okay, let's find the 3.3 power rail, yeah? 3.3 power rail. How we can find that power rail? We have the ENE chip, which is our startup chip, yeah? Start chip, or the microcontroller, or whatever you want to call him. KB3930. I don't think this is the BIOS chip. No, probably not. Probably the BIOS is inside of this one. But anyway, this chip is working with 3.3 volts, yeah, the ENE chip. And I will try What I will try to do, yeah, that chip. This is the chip who will start will start the board. Will start all the power supplies. Will start the clock. You know, this is the main, very important chip. Yeah. On this one, I have no idea what is supposed to be 3.3, but I can check based on some, let's say, this cap. Let's take this cap, yeah, this one. Okay, let's check with the ground to see which is the ground. Well, let me switch in continuity. Okay, ground. That's not ground. This is ground, yeah. So this one probably is going on the one of the pins. Maybe. Yeah. You see it's beeping here. That means here should be 3.3. So you see I just found the 3.3 power rail. Now we have to know from where is the power supply, who supplied the power here. So I'll keep this here and I will check. I will check with some MOSFETs. But this is not something which I can do under the microscope. So I'll try to see from where this comes. So this is beeping, this is plus, so this is 3.3. Oh wait, this is the BIOS chip. Because the 3.3 comes also here. Okay, so from here, this should be going on some... but we don't have coils on this side. The easier is to check with coils. It's not coils here, we have... yeah, we have MOSFETs, but no coils. Not here. No. 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 Not here. Not here. Not here, not here. It's beeping, yeah? Yeah, it's beeping. And not on this small chip. This is like a must to find a 3.3 volts power supply. That's very important. Because we can't go further. So if you know what I try to do, you know, I don't try to fix laptop with schematics. I don't think I saw schematics or laptop schematics in my life. Apart from when I start this YouTube channel, I have some users are sending me pictures with or schematics. And you know, I look on the schematics and it's like, wow, finally now I can have a big picture. It's okay, it's nice, but you can't fix it on that way. It's long. It's too long. Take the schematics, if you have the schematics, study the schematics, check the board with the schematics. It's a little bit too long. If you have time, yeah. Actually, you'll think if you have schematics, it'll be more easy. Maybe it'll be more easy, but will not be more fast. Not this one. I know what is this one. It's everything is sticky here. What is holding here? Okay, the 19 volts connector, the Wi-Fi antenna. the screen connector, have the speakers. Okay, better. Let's take this out. So you understand this is this it's over fixing the laptops, because if you learn fixing the laptops, you'll fix only laptops. If you learn electronics and how all these things works, like each power supply, just taking the power supply, studying the power supply, if you know how that works, you can fix anything which has a power supply, not limiting on the laptops. Yeah. So let's find the 3.3 volts power supply, because we are on that point. Yeah. It will be a little bit hard because you have to keep the. That's ground? No, that's ground. Okay. I'll keep this here and I'll try to find the beeping. A nice hardware. What we can do on the coils, yeah? On the coils. Coils. No, that's too big. You know, let me take this from this pin. Okay, that pin. Maybe it's more easy. Plus processor power supply. Coil. 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 Another coils. Okay. So probably in this case we have a weird power supply without a big coil. It's possible. So let's see where this is going, because it should be going on some power MOSFET. Should go on some chip. Maybe on other side of the board. Not here. Maybe even on this chip. We can have a power supply without coil. Okay. Let's check with. Yeah, that's 100% is 3.3. Okay. And you see, it's coming from this chip which is getting hot. You can see on the multimeter. Look. So you can have a power supply without MOSFETs and without coil. And this is the case, that case. I was thinking if we have two MOSFETs here, probably this is the driver of the MOSFETs. And the MOSFETs, they have a coil and they no, but not this time. Okay, let's come with the power supply here. 3.3. Let's see if we have any short there. 3.3 volts. Let's come on some point, same one. And it's taking no power, that means it's fine, it's not short here. No, it's not short. Nothing is taking power here. Nothing. So in this case, probably I will say, you know what? Probably that chip is gone. But I will not stop yet. 19 volts. Let's come with the 19 and see how much power it's taking. Plus, minus. We have plus here. I think we have. It's not this one. Plus. Okay, let's check here. And it's taking around 170 milliamps. And yeah, this power is taken from this chip. Let's try to see if we have 3.3 still. That one. Volts. Let's try one more time. Plus. And we have same. Oh wait, it's taking 3.3. Okay, that's weird. So actually my chip is working. So we have 3.3. That's bad. Okay, but what that chip is taking 170 milliamps. That's too much. Let's try to resolder that chip. I'm sure that's not the issue. But let's try and resolder that chip. Just want to see that chip moving freely. Okay. Let me check the pins. Need a good clean. No, probably alcohol will not do a better job. So I'll still use the petrol. You know what, we can try with alcohol, but I don't think. Okay, that's alcohol. Same thing. No difference. You can use even water. You know, when it's about sugar, you have to wait the sugar to get melt on the liquid. Doesn't matter what liquid is. Okay, let's try now. He's looking so messy, so messy. Power supply 19. Ground. Plus. Same story. It's not same story, it's less. It's still getting hot. That chip is getting proper hot. Let's see what chip is and what it's doing. Yeah, I know. Right, that's the moment when you wish to have a schematic. Well, we don't have, so what you can do? What you can do? Just find what chip is and check on Google easily. 51. Probably this is a ISL 51125. 511151. TPS, yeah, okay, TPS. Yeah. Five volts and 3.3. Okay. But this schematics is chip driving two MOSFETs, like how I told you. So we have 3.3, two MOSFETs, coil, and 5 volts. And my mouse just died. Let me charge the mouse battery. Yeah, I'm a little bit sick. Ill, sorry. So that's what I'm looking for, the coil, because the coil, you see like here, which will have 3.3. That's how I'm looking to find a coil which is beeping with that cap or with the BIOS chip to find the MOSFETs. But looks like on this situation here we don't have MOSFETs. Maybe we'll have on the other side, yeah. On the maybe we have the MOSFETs on the 5 volts. But let's take these schematics, yeah. Pin number 11. Okay. Pin number 11 Probably that's the output. But we'll see. We have the chip. Let's check together, yeah? Let's switch on the beeping. .3 and we have pin starting from here or from here? No, we're starting from here obviously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, it's not beeping on 11. On which one is beeping? It's beeping here. 1, 2, 3, 4, 5, 6, 7, 8. Pin 8. What is pin 8? Yeah, this... What? We have the dot, yeah. Pin 8. Vreg 3. Vreg 3. Vreg 3 output. Yeah, so it's output 3.3 volts. Yeah. Vreg 3 output voltage. That's the one. Our pin is pin number 8. So it's okay. This is outputting 3.3. So that's fine. Yeah. Let's check the other ones. We have Vreg 5. What is Vreg 5? Vreg 5 probably is 5 volts. And which one is there? Pin 17. Let's see if that one is on short and where it's going, yeah? Check with the ground. Oh, I can't see nothing. 1 second. .31 ohms. It's a little bit too low. Sorry. I know I'm ill. Okay, let's check. If 1 second, let's check if saying the 11 should go on the MOSFETs. 1 second. Pin 11. Pin 11, 11. 11 is this one. Let's check the other pin. So this pin 20 should go on the middle of the MOSFETs. The 5 volts power supply, pin 20. See pin 20. 20. Okay. So this one, and this is going. So this pin, it is going. Pin 20. Let's check with the ground, yeah? First, pin 20 with the ground. And we have 9 ohms. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this pin 20, yeah? We have 10 ohms on the pin 20. But the pin 20, according with the schematics, yeah? Pin 20 should comes on the middle of the MOSFETs. Also the pin 20 should be same with the coil, that means here should be 5 volts. Yeah? So it's not okay to have a short here. What I will check to see where that pin is going. On those MOSFETs from here, pin 20, here. I can't see. 1 second, multimeter. Not here. Twenty ohms. Maybe not here. Let me check with ground again. 9 ohms. Let me check, see exactly where he's going. He's going here on this cap. Okay, you know what? Let's come with 5 volts there and see what's going on there. 5 volts power supply. Let's see what is getting hot. Ground. 1.2 amps. Oh yeah, the chip is getting hot. Yeah, so this chip is shorter than 5 volts. Yeah, it's no, this chip is gone. Okay, so our chip is shorted on 5 volts. That's the issue. Okay, where we can find another chip? That's a good question. I wish I can know. What can I do is just to take different board and look from same chip. Five one one two five, yeah, that's the one. I know this is a long thing. Well, this is a common chip, 51125. I think I saw this chip on many boards. I seen it on many other boards. One second. Okay, sorry for that. Where is that chip? Where can I find that chip? Yeah, you can order the chip, but lasts long. So what you can do is to take all the boards and check on the boards if you can find the chip. That's the chip? Ah, it's not, it's even bigger. What's that chip? That one. 5125. We found the chip. That's the one. That's the one. Probably this is a Sony board because it's blue. And I know Samsung and Sony, they've used blue boards. Okay, let's take that chip down. Quickly. I'm happy we found the chip. Hopefully the chip is good. Let's use the flux. We have the... yeah, okay. How can I bring this on focus? Yeah, now it's on focus. So yeah, sometimes, you know, it's not only you have to replace only the capacitors. Sometimes you have a burn chip. Okay, the pads are looking fine. What do you think? Yeah, there's no damage there. There's no damage. Let's check if we still have short on the pin 12, yeah? Was that capacitor here? And it's not. We have 16 ohms still. What? Let's come with 5 volts. Maybe it's normal. Power supply 5 volts. Ground 600 milliamps. I don't know if this is normal. Yeah? But what I know is not normal for the chip to get hot. That's not normal. So I understand, you know, it's taking 600 milliamps, 1 amp. I understand, but that chip is meant to supply that power, not to consume that power. So obviously, that chip is dead. That's not question about it. Okay, let's take this out. Let me see the chip position. Yeah, the position is fine. We just have to grab this chip out and move the chip on the board. So this is the power supply for 3.3 volts and 5 volts. On our case, the 3.3 was working, but the 5 volts wasn't short and was making the chip to get very hot. The chip is out. Let's move the chip straight away on our board. Okay, let me bring this on focus because I can't see nothing. Okay, like that. Let me use some flux. I'm using around 450, you know, but you can't play with too much heat on this chip because you'll kill the chip. Okay, looks fine, looks fine, looks fine. Let's see now. Let me to cool down this. Just wait 1 second and we'll check with the 19 volts with the power supply to see if it's still getting hot. 19. Okay, it's fine. Let's check. Ground plus is like 10 milliamps. You can see there 10 milliamps. We have LEDs here. Does the board with the LED? No, probably not. I'm curious if we have power. You know, I'm just curious. But yeah, let's put the board back. Let's check. So again, from all the laptop, yeah, all this big motherboard, what you have working all the time, yeah. So think, yeah. You think that when the laptop is off, is nothing there? Yes. You have a switching power supply who is switching and switching, you know, without stop. The 3.3 and 5 volts, which usually it's with a chip, and I didn't see so many like from the output of the chip going to the, you know, no, they usually they drive two MOSFETs and a coil. But in our case, you know, it's just when you don't need power, you don't need to use MOSFETs. You don't have to use MOSFETs. Like this case. So in this case, probably the 3.3 volts power supply is used only to drive that chip, to power up that chip, the startup chip and the BIOS chip. Okay. The lights I think are here. Maybe. Oh yeah, we have the lights here. Okay, okay, that's good. That's good. I just want to clean this connector to be sure it's fine. I just want to see the lights. If we have lights when we plug the power. Okay, let me plug the charger. And even we can check the 5 volts, we can check the 3.3. I don't think the 5 volts should be on all the time. Okay, it's no light. I know, that's bad. Let's check the voltage, yeah? Volt. Okay. Pin 20, 21, sorry, or 20, I don't know, I don't remember, is 0. Nothing. Okay. And 3.3. 3.3 is on. That's normal, you know. I was thinking it's no point to be 5 volts there, so 3.3 is enough. Okay, let's try to power up this laptop. Where is the power button? Where the power button should be? We have a cable who comes there. Power. And power, it's on. And they have power light. We have no picture on the screen. We have power on the power button. And it's off. That's good. Let's learn to power up the computer without the power button. Yeah? Touch IC, yeah, 60. Yeah? The things, it's like a queue, so probably will be ready later on today around 5 o'clock. Yeah, I know. I know. No, sorry, Saturday I'm off. Any day, but not Saturday. Yeah, Friday is fine. Yeah. Thank you. Okay, let's see. Let's plug the charger. Let me. Yeah, Azlana. You know, let's take out the board. Okay. Okay. 1 second. Sorry. So we took the board out. Let's put the board so we can see exactly what happened. Power button. We have blue light. And you know what? I just want to see if the processor is getting hot. Oh yeah. Now it's shutting down by itself, you know, because obviously the processor is getting hot quickly. And the processor order shut down, you know. That's why it's coming on and goes off. Let's use the heatsink. I'll not clean nothing now, I'll not change the thermal paste now, that I'll do on the end after it's working. So I'll just put the heatsink here. Let's put the screws. not these ones.
Why 3 o'clock?
1 second, 1 second. The heatsink is here, let's even the graphics. Okay. Let's try now, yeah? And we have picture. We have picture on the screen, yeah? You can see? It's not very bright, but it's okay. So we have picture on the screen. Yeah? Of course I'll put all back together. It's no point to assist on me putting all back together. And now probably, now if we'll check, we have 5 volts there. What? Yeah, 5 volts. So actually the 5 volts power supply is not even working if the laptop is on. If the laptop is off. But because something was messed up inside of the chip, that chip was getting hot on 5 volts. So you understand what's the point? Yeah? The point is when you know how these things works, yeah? And this is a complicated, it's not complicated, no, it's, don't get me wrong, this was like a basic thing, you know? Usually if I don't have to do the video, I will spend even less. But this is an example, a clear example, yeah? How you can treat the things. Don't treat him like a laptop. No. Treat the things. You know, what do we know? We know if the laptop is off. I don't even care if it's coming on. But what I know if the laptop is off, I should have 3.3 volts. And I did have 3.3 volts, but the chip was getting very hot. Obviously, just think, when you press the power on button, it's a lot of things happen, including the 5 volts power supply starting the 5 volts. That 5 volts is using for something else to power up the laptop. And let me take out the power. So you understand, it's like a chain reaction, and everything should be fine there to this chain reaction to work. Yeah. So that's what I'm trying to explain. And if you have issue, like how I have today here, you don't know what the chip is doing, you don't know what to check, go on Google, take the data sheet, and you can see exactly what that chip is doing and what's going on there. Yeah. It's not so hard. Just you have to treat everything separately, not like a laptop motherboard or like a system, like a full no, everything, you know, you have 3.3. Yeah. Yeah. Yeah, today, yeah, by 5 o'clock, yeah. Yeah. Yeah, it's okay, tomorrow is fine. Thank you. Yeah. So just think, yeah, you have power supplies, 3.3 and 5 volts altogether. That's for the startup. That's the chip who start the board. Yeah, this is the chip who will read the BIOS chip. You read is the BIOS chip. It's a program there. The chip will start doing the auto test. 1 second. Sorry. So it's doing the auto test. If all the components passing the test, you know, the RAM memory, the processor, the graphics, finally he will start displaying. Yeah. Okay. Thank you for watching. Like and subscribe if you like the video, and see you later. Yeah, I think later. Yeah, we have more jobs there. Yeah. Bye.